Good morning, students. Welcome back to science class on the chapter motion. Today also I will ask questions. So please put your answers in your comment box. Okay. So first one, I will write the question. Okay. See here. Uh, First question. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3.0 meter per second. See here, accelerates. Okay, accelerates in a straight line at a constant rate of 3.0 meter per second. Okay, for 8 seconds. For 8 seconds. How far does the boat travel during this time? Okay. Yes, sir. Find the answer for this question. Quick. I'll give you 2 minutes time. First. So Sangeeta Kokunde answered, sir, it is 80 seconds or 8 seconds. Sir, it is 8 seconds. Okay. I erase this one. 8 seconds. 8.0. Okay. Yes. First. Yes, Akkama Devi Patil answered 9.6 centimeter. No, why it is in centimeter? See, acceleration it is in meter, right? Okay. 9 centimeter wrong. Yes, it is 8 seconds. Okay, for 8 seconds. For 8 seconds. Quick. Yes, what is the answer? First. I'm waiting for your answer. Quick, quick. Yes, Sharanu Sahukar, it is 96 meter. Correct. The answer is 96 meter. Okay, only one student answered correctly. Yes, 96 meter, 96 meter. Correct. See here, first. Okay. A motor boat starting from rest. So starting from rest means clearly we can say that initial velocity is equal to 0. Okay. So initial velocity is 0 and accelerates in a straight line, that is A is equals to 3.0 meter per seconds. Okay. Then for 8 seconds. So t equal to 8 seconds. We need how far does the boat travel? It means we need yes. Okay. So which formula here? We have three formulas, right? So first one, V is equals to U plus AT. Then second one, S is equals to UT plus half AT square. Okay. Then V square equal to V square. Third one, V square equal to U square plus 2A 2A yes. V square equal to U square plus 2A yes. See here. So now you can directly go with the second one because here we need S, right? We know U and T value and A value. So better go with second one. Okay. S is equals to UT plus half AT square. Okay. So substitute the values. S is equal to U value is 0 into T value is 3 plus half into A value is sorry T is 8, right? 8 and this is 3 and this is 8 square. Okay. Next 0 into 8 that is 0 plus 1 by 2 into 3 into 64. Okay. 2 ones are 2, 3s are 9, 2s are. Clear? So then 32 into 3, 32 into 3 that is 96 meter. Okay. See, here two questions. See, which of the following is true for displacement? Which of the following is true for displacement? So first question, it cannot be zero. Okay, first question, it cannot be zero. Then second one, its magnitude is greater than the distance traveled by the object. So here, first say whether these two are statements are true or false. See for displacement and give the answer. Quick. Sandhya Kulkarni answered B option. What is that? What is that B option? Which of the following statement is true? Do you think that the second one true? Its magnitude is, see, magnitude means what? A numerical number. For example, say 10 meter, 5 meter, 10 seconds, or 30 degrees Celsius. So we call that is magnitude. Okay. So here, its magnitude is greater than the distance traveled by the object. Its magnitude means the value of the displacement is greater than the distance. Okay, so now out of these two, tell me which one is true and which one is false. Second option is true. Before giving the answer, just think. Okay, its magnitude means what? Displacement's magnitude. Read the question carefully. Okay, displacement's magnitude is greater than the distance traveled by the object. Okay, its magnitude is greater than the distance traveled by the object. Yes, what is the answer? First, yes, both are wrong. Okay, correct. But give the reason why both are wrong or why both the statements are false. Why both the statements are false? Both are not true. Yes, correct. Give the reason why. It can be zero. And the magnitude will be always less than the distance, not always, sometimes because the displacement may equal to this distance, right? Okay, see here. So first one clearly we can say that it's false. It can be zero. See here. So if one object, say it will first it will travel say 10 meter distance. First it will travel A to B, then B to A. At that time displacement is zero. Why? Because initial and final positions are same. Okay. Next, its magnitude means displacement's magnitude. See here. See, one object will travel A to B. Now we can say that distance is 10 meter, then the displacement is also equal to 10 meter. Now take one more case. That object will travel from A to B, B to A, then A to B. So in this case, the distance is 30 meter. What about displacement? In this case, displacement is equal to 10 meter only. Correct? So that's why the second statement is also false. Why? Because see, displacement, it cannot be greater than distance. Okay? Yes. Next one. Okay. Yes, sir. Before that, see, I have not explained scalar quantity and vector quantity. Okay. So scalar, first I will explain scalar quantity. Scalar quantity. Okay. See, scalar quantity means it has only magnitude. It has only magnitude. Magnitude means what? One numerical number. Say for example, 10 meter, 15 meter, 5 second, 10 second, then 10 ampere, okay, then 30 degree Celsius, 5 kg. These are what? Magnitudes. Okay, magnitude means what? One numerical number. So now scalar quantity. Scalar quantity which has only magnitude and it doesn't have which one? Direction. Okay. See, I'll say distance is example for scalar quantity. Distance is example for scalar quantity. Say A to B 10 meter. See, you can travel A to B. See, using this path, straight path, or you can travel using this path, or you can travel using this path, or you can first go here, then you can reach B. Okay. See, distance means what? See, if you travel using this path, then this is your distance, right? This will become your distance. Clear? So here there is no particular direction here. Okay. See, if you travel like this, you can reach. If you travel like this, you can reach. Okay. But you will cover some distance. Clear? But here there is no particular direction, right? So that's why distance is a example for scalar quantity. Then say mass. Mass is also example for scalar quantity. See here because I will say mass is 2 kg. Mass is 10 kg. See, I will ask what is the weight of this duster. Okay, you will say 5 gram. Or say just weight is 1 kg. Okay, so mass of this duster is 1 kg. To understand that it is mass, just we need that value, right? Just we need that value. We don't want any direction here. Clear? For example, I will ask what's the time taken to travel from one place to another, say A to B. You will say that what 10 seconds. Just you need a time, right? You don't want any direction. Okay, so that's why mass is example for scalar quantity and time is also scalar quantity. Okay, then see here. Now we know the formula. What is that? Speed. So speed equal to distance. Speed equal to distance by time. Now I will ask speed whether it is a scalar quantity or vector quantity. See here. Speed equal to distance by time. So distance is scalar quantity. Then the time is scalar quantity. So both are scalar quantity. So that's why speed is also scalar quantity. So clear, right? What is scalar quantity? So scalar quantity which has only magnitude, which has only magnitude and no direction. Okay. Next move to. So now can you give other examples for scalar quantity? Mass is scalar quantity, time is a scalar quantity, distance is scalar quantity. See, I let example for scalar quantity. First one mass, then second one time, third one distance, fourth one tell me fourth one mass, distance, mass, time, distance, then speed. So now give other examples. First, distance, speed, and other examples for scalar quantity. See, some physical quantities, if they have only magnitude, no direction, then we call those are scalar quantity. Quick. You know, temperature, for example, I will ask what is the room temperature. So you will say 20 degrees Celsius or 37 degrees Celsius. So just here we need one value, right? Just here we need magnitude. We don't want any direction. So that's why temperature is also example for scalar quantity. Temperature is also example for scalar quantity. Okay. Next move to vector quantity. So vector quantity means it has both magnitude and direction. It has both magnitude and direction. Okay. Vector quantity. It has both magnitude and direction. See here. See, A to B 10 meter. Now say this is a point is in south and this is in north. Okay. So now I will ask one object is traveling A to B. Now I want to calculate displacement of that object. How to calculate? Okay, I need displacement of that object. Then that object it should travel A to B in this path only, right? Okay, if that object travels using this path, then we won't call it as a displacement. Sorry, displacement. Okay, if you want to calculate displacement of that object, then that object it should be travel in this path only. It means it should not travel in a straight line, or it should travel in one particular direction. Clear? It should travel in a particular direction. Clear? So now, if you want to calculate displacement of that object, then that object it should travel from south to north. See, for while calculating a distance, if first here that object will travel here, then it will reach B. Here no need any direction. Okay, but for displacement, that object it should travel in this straight path only. It should travel from south to north only. Okay, so that's why displacement it has direction. So displacement is a example for vector quantity. It has a direction and also it has magnitude. Magnitude is that is 10 meter. Okay, so displacement is a example for vector quantity. Then now tell me other example for vector quantity. First one, displacement. Displacement is an example for vector quantity. Other examples, yes, velocity is also example for vector quantity. Why? Because see here, we know the formula. Velocity is equals to displacement by time. Displacement by time. Here displacement is vector quantity and time is scalar quantity, but overall it is what velocity is an example for vector quantity. Okay, so velocity is example for vector quantity. Then other examples for vector quantity. Yes, the force is also example for vector quantity. Why? Because see here we know the formula. Force is equals to mass into acceleration, right? Okay. And you know whatever acceleration, whether it is scalar or vector, acceleration is example for scalar or vector. Yes, tell me whether acceleration is example for scalar or vector. Yes, acceleration is example for scalar vector. So here force equal to mass into acceleration. Mass is the scalar quantity. This is vector quantity. So that's why overall we'll say that force is example for vector quantity. So force is example for vector quantity. Then acceleration is also example for vector quantity. Okay. Yes. So next question. distinguish between speed and velocity. Distinguish between speed and velocity. Distinguish between speed and velocity. So speed and velocity. Okay, see here first. So speed is, it is a distance covered by an object in a given time. Then velocity, it is the displacement covered by an object in a given time. Then second one, so speed is an example for scalar quantity, and velocity is example for vector quantity. Okay, and formula, so speed equal to distance by time and velocity equal to displacement by time. Okay, yes sir. So now I will write one question. See here. During an experiment, during an experiment, a signal, a signal, signal from a signal from a spaceship reached the reached the ground station in 5 minutes. 5 minutes. What was the distance? What was the distance? What was the distance of the what was the distance of the spaceship from the ground station? Ground station. The signal per second. So clearly here we need distance. So don't use any equations of motion. Just use speed equal to distance by time. Okay. So tell me what is the answer for this question? Quick. Okay. So here use speed equal to distance by time. See here, this is Earth. Okay. This is ground station, and here one spaceship. Okay. So here we are getting signal from the spaceship. So calculate the what is the distance between spaceship and ground station. Okay, that signal is traveling. That speed is equal to 3 into 10 raised to the power 8 meter per second. So in 5 minutes. Okay, do it. First, tell me the answer. Yes, here speed equal to 3 into 10 raised to the power 8 meter per second. Then time is equals to 5 minutes. That is 300 seconds. So we need distance. Okay, we know the formula, that is speed equal to distance by time. So that is S equal to d by t. So bring t this side and right here. So S into t equal to d, or d is equals to S into t. So speed is 3 into 10 raised to the power. Speed is 3 into 10 raised to the power 8 into 300. Okay. Yes. Tell me the answer. Quick. Yes. What is the answer for this question? Quick, quick. First, what is the answer for this question? Just multiply 3 into 10 raised to 8 into 300. See here. So now I'll write here distance is equals to 3 into 300, that is 900 into 10 raised to the power 8. So now we can write this 900 as, see, this is your answer, no problem, that is 900 into 10 raised to the power 8. So we can write this as 9 into 10 raised to the power 2 into 10 raised to the power 8. Clear? Okay. So now we cannot write that a to the power n into a to the power m is equals to a to the power m plus n. So distance is equals to 9 into 10 raised to the power 10 meter. Okay. So this is the answer. Next one. Our bus decreases bus our bus decreases its speed from 80 kilometer per hour to 80 kilometer per hour to 60 kilometer per hour in 5 seconds. In 5 seconds. So find the acceleration. Find the acceleration of the bus. Acceleration of the bus. Yes. So tell me, what is the answer for this question? So first convert into meter per second. So obviously it's the speed from 80 to 60. So in 5 seconds. Quick. Yes, what is the answer for this question? So here velocity changes from 80 to 60, right? So clearly we can say that initial velocity u is equals to 80 kilometer per hour. So convert into meter per second. Already you know, right? 80 into 5 by 80. Okay. Then final velocity is 60 kilometer per hour. So 60 into 5 by 80. So what is the answer? Quick. So t is equals to 5 seconds and we need acceleration. First, tell me the answer. Yes, what is the answer for this question? Yes, so 22.22. Initial velocity is 22.22. 22.22 meter per second. Then what about final velocity? Final velocity. Final velocity. What is the final velocity? So initial velocity is 22.22. So that is 16.166. Correct. 16.166 meter per second. Okay. Yes, we know the formula acceleration A v minus u divided by t. So v is 22.22 minus u is 16.166 divided by 5. And tell me the answer. So what is acceleration? What is the acceleration? So acceleration is minus 1.12 meter per second square. Okay. So here we got negative. Why? So here acceleration it is a negative, right? Why? Why? Because here the velocity decreased, right? Here velocity reduced from 80 to 60. So that's why we got acceleration negative. Okay. I will stop here. So tomorrow I will continue the class. Thank you.